Can you hear me? Okay. Great. Can you see my screen? Okay. So now we will start within 1 minute. Just wait for more people to show. Okay, so let's start. Hello everyone, my name is Amer Music. I'm application engineer here at DV Power. I work here for 2.5 years. Before that, I used to work in an oil field back in Libya, where I was involved in all type of commissioning activities, including commissioning of the battery system. Today's topic is on battery charging procedures, and we will focus on how to charge batteries depending on their chemistry. So first things first, let's talk about the batteries. First, batteries can be found everywhere, and as we know, the applications where we can find batteries are increasing every day. It's an upcoming market. So we can find batteries in electric generating stations at substations, where they are used for protection and control of switches and to power supply the protection relays. Batteries can be found in telecom systems to support phone services, especially emergency services. We can find batteries in industrial applications, where they are used, pretty much the same as in electric generating stations and substations, so for protection and control. We can use batteries as a backup of computers, especially financial data and information, and we can use batteries in a lot more applications. We are all aware about the electric vehicle industry. We can find batteries there, and we can find batteries in a lot more applications. For example, in hospitals, you know that the hospitals has life support equipment, and those equipment is electrically powered. So what will happen if there is no grid power, if there is a grid outage? So the people would die. And what happens when there is no grid power in hospitals? Well, the diesel engines will start and they will provide enough electricity to supply everything. But the diesel engines cannot start immediately. You need them to start, you need them to synchronize, because it's always more than one. And that is a process that can take up to 20 minutes. And what will happen in that time gap when there is a grid outage, between the grid outage and when the generator starts to supply full electricity? Well, the whole system is rely only on batteries for those 20 minutes. That's why the batteries must be in a good shape. And how we can be sure that the batteries are in a good shape? By testing them and by properly maintaining them. And the best test of the batteries are discharging test, or the capacity test, as we call it. And the capacity test is consisted of two parts. First part is a discharging test, where we are discharging the battery to measure the actual capacity of the battery. And at the end of the test, at the end of every single test of electrical equipment, we need to have a functional equipment. And when we are perform the discharging test, at the end of the discharging test, we don't have a functional equipment because the batteries are discharged. That's why we need to charge the battery. And that's the second part of a capacity test. So first one is a discharging test, and the second one is a charging test. I already said that the battery can provide a bunch of the different type of loads. They can provide AC and DC equipment. Of course, the battery itself gave the DC output current, but if you have inverter, then you can supply AC devices with no problem. So now we will speak about the battery charging with a focus on procedures for charging a different type of battery chemistries. So what is a battery charging? It's a process where electrical energy from the charging source, from the battery charger, is being stored into chemical energy of the battery. There are a lot of charging methods in the world. This is only a list of few of them. And they largely depend on the type of battery. But they don't only depend on the type of the battery. Sometimes the charging method depends on the application. That's why when you are buying the battery, first you need to check if that battery is suitable for your application. And then when you buy the battery, you need to follow all the manufacturer's instructions regarding the installation, regarding the maintenance, regarding the discharging process, and regarding the charging process. Because there is no uniform standard in the world that dictates the procedure of charging the batteries. We are relying on the manufacturer's recommendations. Sometimes manufacturers don't provide that in their usual small brochures, but if you ask them, they will provide you with all the information regarding the charging current, the voltage threshold, etc., etc. They will provide you that, but you need to ask if it's not available in the battery brochures online. So chargers are commonly identified by their charging speed. Consumer products. I will speak a little bit about consumer products because main focus of this presentation will be industrial application and in industrial batteries. But consumer products come with a low-cost personal charger that performs well when used as directed. The industrial charger is often made by the third party, not by the manufacturers of battery. And those chargers include special features such as charging at adverse temperature, for example. Although some batteries can operate below freezing, not all chemistries can be charged when cold, and most lithiums fall into this category. So what is important here? When you buy the batteries, you will get a table, and sometimes in that table you will see that the battery can work on 0 degrees Celsius, and that is okay. But you need to know that the working conditions are one thing, discharging conditions are second thing, and the charging conditions are completely different thing. So if you see in a manufacturer data sheet that the battery can work on 0 degrees Celsius, that only means that the battery can work on 0 degrees Celsius, not that you can charge the battery at 0 degrees Celsius. That especially applies for the lithium-based batteries. Regarding the charging speed, the most basic charger is the overnight charger, also known as a slow charger. We can find that in industrial application. The rapid chargers fall between slow and fast charger and is used in consumer products. And the fast charger can be found in consumer products and in industrial applications. But in industrial applications, people and manufacturers are trying to avoid this fast charger. And we will see why. Now we will go through some battery charging tips that can apply for every battery chemistry. First one is then charging a battery is most effective when state of charge is low. So charge acceptance decreases when the battery reaches, say, state of charge of 70% and higher. A full charge battery can no longer convert electrical energy into chemical energy, and charge must be lower to trickle or terminated. So when you are charging the battery, you will see that from, let's see, 30% up to 75%, you charge well fast. And then from 75 up to 100%, it really takes a time. And that is because the battery is converting electrical energy slower into chemical energy when above this 70% state of charge. Charging a battery beyond full state of charge turns excess energy into heat and gas. With lithium-ion, this can result in a deposit of unwanted material, and prolonged overcharge cause permanent damage for all battery, especially for lithium-ion. You need to use the correct charger for the intended battery chemistry. Most chargers available on the market serve only one chemistry. And you can buy the charger for lead-acid battery, the charger for lithium battery, and etc., etc. There are only a few companies that provide the battery chargers for a variety of chemistry. A high wattage charger shortens the charging time, but there are limitations as to how fast the battery can be charged because of this excess energy that we spoke about. Now we will speak about the charging of a lead-acid battery. They can be charged in a lot of ways, but the first one and the widely used one is, we call it EU mode. It's a two-step process. It starts by charging the battery with the constant user selectable current. On this graph, you can see that user selectable current here in a dashed line, and you see in the stage 1, the current is constant, and the voltage is rising slightly up to pre-selected boost voltage level. When the boost voltage level is reached, then we are entering the second stage of charging process. It's a constant voltage charging, and during that process, the battery charger keeps the voltage at the predefined level, boost voltage level, and the current slightly decreases. Charging is stopped when a pre-select minimum current value, which indicates a full charge, has been reached. That is really low value. That is a value below 0.5 amps. Of course, this is a basic method of charging lead-acid batteries, and there are a lot of varieties on this method, and this is one of them. So first two stages are the same. So you have a constant current, voltage rises, and then when pre-selected boost voltage or equalize voltage, you can call it whatever you want. You can find somebody calls it boost voltage, and sometimes they call it equalize voltage, but that's the same thing. And when that voltage is reached, then the charger keep that voltage constant, and the current decreases up to pre-select value. And then when this pre-select value is reached, then the charger is going to the third stage. It's called float charging, when the charger provides enough energy to keep voltage at the float level, which is lower than the equalize level. And that float level is kept for a certain amount of time. Usually it is user selectable. And after that, when the float time is finished, then the charging process is finished and you have a charged battery. Second way to charge the lead-acid battery is with UU mode. So this is a constant voltage charging until the battery reached the pre-select boost voltage. Boost current is user-defined, but sometimes boost current is reached and boost voltage is not reached. In this case, the charger keeps that maximum pre-selected boost current until the boost voltage is reached. And then when the boost voltage is reached, the charger will source enough current to hold the voltage of the battery at this constant voltage for a certain amount of time, which is user selectable and which is provided by the manufacturer. And here is typical settings for the lead acid battery. So float voltage is from 2.25 up to 2.27. Of course, you need to follow the manufacturer's recommendation if you have a battery at site, because the manufacturer will provide you the float and boost threshold. Typical boost voltage threshold for lead acid batteries is from 2.3 up to 2.45 volts. And the total charging time for lead acid batteries are 12 to 16 hours. This is some tips when charging lead acid batteries. First is to charge in a well-ventilated area, because hydrogen gas generated during charging process, well, it's explosive. So you need to have a ventilated area for charging the battery. Second, you need to choose appropriate charging program for flooded GAL and AGM batteries. You need to check manufacturer specification on recommended voltage threshold, as we speak about. Third thing is you need to recharge lead acid batteries after each use to prevent sulfation. And it's important to underline here that the lead acid battery cannot be stored on low charge. Then the next thing is the plate of flooded batteries must always be fully submerged in electrolyte. You need to fill the battery with distilled or deionized water to cover the plates if low. Never add electrolyte, just deionized water or distilled water. But this water level must be filled after charging. Why? Because overfilling when the battery is on low charge can cause acid spillage during charging, you know. And that's why you need to always add this water after charging. The formation of gas bubbles in a flooded lead acid indicates that the battery is reaching full state of charge. So that's one of your indicators that the battery is reaching full state of charge. You need to lower the float charge voltage if the ambient temperature is higher than 29 degrees Celsius. Of course, this point cannot be taken for granted. You need to check with the manufacturer about this threshold. It's usually 29 degrees Celsius, but sometimes it's lower, and sometimes it is even 31. And you do not allow acid to freeze. An empty battery freezes sooner than one that is fully charged, and that's why I said before, do not store batteries on low charge, especially in cold conditions. They can freeze, and if lead acid battery freeze, then you can throw it in the trash. You cannot use it anymore. I spoke about the equalizing charge. Equalizing charge is generally performed as a part of periodic maintenance. The intent of equalizing charge is to remove sulfation that form as a result of undercharge. Equalizing charge must be time limited. It doesn't, well, it couldn't take a long time. I mean, it's not advisable for equalizing charge to last long. And this equalizing charge works only on lightly sulfated batteries. If you have heavily sulfated batteries, then equalizing charge will not help. Well, basically, if you have heavily sulfated batteries, I think nothing will help. That those batteries are ruined, and nothing can help them. So in a normal charging, you have a voltage threshold around 2.4 volts per cell, and you are charging the battery, and that is normal. But in so-called equalized charging, that voltage threshold is higher, so it's around 2.5, even 2.6. And that can help to remove the lightly sulfatization on your batteries. The equalizing charge is applied when you perform a heavily discharged battery, I don't know, performance test or something, and after that you need to charge the battery, and after the charging you just add this higher voltage level to do the equalized charge. You do the equalized charge if specific gravity of any cell is more than 10 points below the full charge value while on float, or if the voltage of any cell is more than 0.04 volts below the average cell voltage when the battery is on float. This can be checked during regular maintenance with only the voltmeter, and if you notice this, then you need to perform equalized charge. Or if distilled water was added to the battery, an equalized charge must be performed to restore specific gravity and to bring all voltage of all the batteries to, well, pretty much same level. Regarding the nickel-based batteries, well, they are more complex to charge than lithium-ion and lead-acid batteries, because both lithium and lead-acid battery systems are charged with a regulated current to bring the voltage to a set limit after which the battery saturates until fully charged. This method is called constant current, constant voltage. Nickel-based battery also charged with constant current, but the voltage is allowed to rise freely, as you can see on this diagram. So there is no, you cannot predict how the voltage will behave during the charging process of nickel-based batteries. There is no defined line, there is no voltage rise, because sometimes the voltage can even drop. But you need just to set the maximum voltage, the threshold, and everything between the current voltage level while you are starting the charging process and that limit is, well, you cannot predict it, and that's normal. That's normal for nickel-based batteries. The most important thing about nickel-based battery is full charge detection. That occurs by observing a slight voltage drop after steady rise. So when the voltage limit is reached, you will see the slight drop. When you notice that slight voltage drop, you know that your battery is charged. Widely used method for charging nickel-based batteries is a EU mode. So this is charging the battery with the constant user selectable current, as we can see here on the dashed line, and this continues up until the battery voltage reaches the predefined voltage, 1.5 volts per cell, something like that. It's always given by the manufacturer, but it's always around 1.5 volt per cell. Full charge detection is by observing a slight voltage drop after a steady rise, and we can see it at the end of the diagram here. The most important thing to underline here is that there is no charger on the market that can spot this voltage drop. That's why you cannot charge lithium-ion battery properly without human interaction. You need to observe the voltage graph, and when you spot this, you need to manually press stop and manually terminate the charging process of nickel-based batteries. So battery manufacturers recommend that new batteries be slow charged for 16 to 24 hours before use when speaking about nickel-based batteries. Slow charge is good because it brings all cells in a battery pack to an equal charge level. This is important because each cell within nickel-cadmium battery chemistry may have self-discharge at its own rate. Full charge detection of sealed nickel-based battery is more complex than that of lead-acid and lithium-ion, and low-cost chargers often use temperature sensing to end the fast charge, but this is inaccurate because the core of a cell is several degrees warmer than skin where the temperature is measured. And the delay that occurs causes overcharge. Charger manufacturers use 50 degrees Celsius as a temperature cutoff. So I already said that there is no charger on the market that can spot this voltage drop. And that's why they are using the temperature as a terminating factor for a charging of nickel-based battery. But that's not advisable, because the temperature on the terminals of the battery where you can actually measure it, it's not the same as the temperature in the battery core. And that's why it's not advisable to use a temperature as a terminating factor for a charging battery, especially nickel-based battery. And also this can apply to a lead-acid system. Also, do not use temperature as a terminating factor for charging both lead-acid and nickel-based batteries. They inflict harmful overcharges when a fully charged battery is repeatedly removed and reinserted. Of course, flooded nickel-cadmium battery is charged with a constant current to about 1.55 volts per cell. Sometimes it's 1.5, sometimes it's even 1.48. It depends on the manufacturer's recommendation. So you need to strictly follow the manufacturer's recommendations while charging all types of battery, not only nickel-based. While speaking about lithium-ion charging, a lithium-ion charger is a voltage-limiting device that has similarity to the lead-acid system. You will notice that the behavior is pretty much the same, but the main difference is that lithium-ion has a higher voltage per cell, tighter voltage tolerances, and the absence of trickle or float charge at full charge. While lead-acid offers some flexibility in terms of voltage cutoff, manufacturers of lithium-ion cells, they are very strict on the correct settings, because lithium-ions cannot accept overcharge. You know, they can set on fire if overcharge. So the so-called miracle charger that can be found online that promise to prolong the battery life and gain extra capacity of lithium-based batteries with pulses and other gimmicks, that doesn't exist. So lithium-based batteries must be strictly charged in according to manufacturer's recommendations. They don't accept overcharge. You can set the batteries and set yourself on fire if doing so. The best method of charging the lithium-based battery is EU mode. So you charge the battery with the constant user selectable current, same as for the lead-acid batteries. And this continues until the battery reaches the predefined boost voltage. When this voltage is reached, device switch to the constant voltage charge, and this is stage 2. And the charging is stopped when a preset minimum current value, which indicates full charge, has been reached. So it's pretty much same as for the lead-based system. Only lithium-based batteries cannot be used immediately after charge. So they need to be like, well, left for a certain amount of time with no current, just for all the cells in the pack to reach optimum level. Rated voltage. This boost voltage for lithium-based battery is something somewhere around 4.2 volts per cell. So lithium ions with traditional cathode materials of cobalt, nickel, manganese, and aluminum typically charge to 4.2 volts per cell. The tolerance is plus minus 50 millivolts per cell. Some nickel-based variety charge to 4.1 volts per cell, and the high-capacity lithium-ion may go to 4.3 volts per cell, and even higher. Boosting the voltage increases the capacity, but going beyond specifications, so going above that, stresses the battery and compromise safety, because you can set them on fire, as I already said it. Full charge of lithium-based batteries occurs when the battery reaches the voltage threshold and the current drops to around 3% of the rated current. Also, a battery is also considered fully charged if the current level, if the current goes down, it cannot go it cannot go any lower, and you can spot that for a certain amount of time that the current is low. For example, 0. some amps, and it doesn't go any lower, so you can stop the charging process because your battery is charged. Some lithium-ion packs may experience a temperature rise of about 5 degrees Celsius when reaching a full charge. This could be due to protection circuit and or elevated internal resistance. Increasing the charge current doesn't hasten the full charge state by much. And the advised charge rate of an energy cell is between 0.5 C and 1 C. The complete charge time is, as stated here, about 2 to 3 hours. Manufacturers of these cells recommend charging at 0.8 C or less to prolong the battery life. However, most power cells can take a higher charge C rate with a little stress. So lithium-ion batteries, they operate safely with this designated operating voltage. However, the battery becomes unstable if inadvertently charged to a higher than specified voltage. So if you have a battery that can be charged to a 4.2 volts per cell and prolonged charging of that type of battery above 4.3 volts per cell, well, it will plate a metallic lithium on the anode, and the cathode material will become an oxidizing agent, and it will lose stability and produce carbon dioxide. Venting with flame is connected with the elevated temperatures, so a fully charged battery has a lower thermal runaway temperature and will vent sooner than one that is partially charged. You see here the threshold, the temperature threshold for lithium cobalt at full charge is 130 to 150 degrees Celsius. Nickel manganese cobalt is 170 to 180 degrees Celsius, and lithium manganese is about 250 degrees Celsius. But lithium-ion is not the only battery that possesses a safety hazard if overcharged. Lead and nickel-based batteries are also known to melt down and cause fire if improperly handled. So you have, in all types of battery, you have effects of overcharging and undercharging. And that's why it is highly advisable to use the manufacturer's recommendation to avoid both of these, because they both can cause a severe damage on your battery, because overcharging can produce heat, which, as already said, it's fatal for the especially for the lithium-based battery. And it can produce gassing, which is also fatal for all type of battery. And undercharging can cause sulfation. And if you have severe sulfation of the batteries, then especially when we are speaking about a lead-based battery, then they are destroyed. You cannot use them. And that's why you need to charge the battery in according to manufacturer's recommendation, and you need to charge the batteries every time after discharging, to avoid that the battery are left for a long time in undercharged, to avoid this sulfatization process. So, as can be seen in this presentation, the charging procedures are different depending on the battery chemistry, which is completely contrast of the discharging process, because discharging process is pretty much the same for all type of chemistries, but charging process is different, and that's why it is even more important to follow the manufacturer's recommendation during the charging process than for the discharging process. Because if you are speaking about the discharging process, you have some standards that dictate how to perform them. But for the charging process, well, there is no no standard that will lead you point by point on how to perform it. So we need to rely on a manufacturer's recommendation. While speaking about DV power products, we have our battery charger series. We call them BAC series. We have two models, BAC 25A and BAC 50L. They are lightweight, only 10 kilos of weight. BAC 25A can charge the batteries from 10 up to 300 volts with the current up to 25 amps. And BAC 50L can charge the batteries from 1 up to 60 volts with the current up to 50 amps. Most important here is to underline that our BAC series devices can charge all type of battery chemistries, all type, even nickel-based batteries, which, as we see, is pretty hard to charge, and it's pretty hard to observe, and it's pretty hard to determine when they are fully charged. So our charger has a controllable charging processes. We have two modes, EU and UU modes. I spoke about those two modes in this presentation. We have this temperature compensation charging option when you are charging in a temperature that is different for 29 degrees Celsius, as already said, and we have alarms to prevent excessive charge. And our BAC devices can be used as a universal replacement unit when the stationary charger is not working, or our charger can serve as a DC power supply if the battery is completely discharged and excluded. Our charger can work in parallel with stationary battery charger in your substation in order to recharge the battery faster after the heavily discharge. Of course, our charger can be used to charge single cell if you want to replace, for example, you are replacing the bad cell from your battery string, and you stored battery. That stored battery must be charged before installed. That's why we have this 50L model that can charge the batteries from 1 volt, so you can charge even one single cell. And our charger can be used to equalize charge for specific cell which show the voltage deviation. This is a table where you can see the maximum charging current for different voltage levels. You can see here we have two models, BAC 25A and BAC 50L. You see that BAC 50L can charge the batteries up to 24 volts nominal with a 50 amps, and then 48 volt nominal can be charged with 50 or 25 amps depending on the mains voltage on your grid. And the same is for the BAC 25A. So that would be all for this presentation. I will just see how many if you are. So if you have any questions. So if you have any questions, you can type here, or you can send me an email on amer@dvpower.com, and I will be happy to answer. Yes, of course, you can have my presentation. I will share it with you, but please just send me an email. I will type here my email. This is my email. Just send me a mail, and I will reply you with the PDF version of this presentation. No problem. Of course, I repeat, if you have any question regarding battery charging, actually, if you have any question regarding the battery testing, you feel free to send me an email, and I will try to provide you an answer and everything that you need. thank you very much for participating in this webinar. I hope you enjoyed, and I hope that we will see you in other occasion. Okay. Okay, so there is no questions here, so I will end this presentation by okay, yeah. Okay, thank you very much. Thank you. Okay, so I will thank you very much for your time and hope to see you again. Bye bye.